Hey everyone, welcome to the stream. Hey Lisp Gamer, thanks for joining. Alright, so I'm going to continue pretty much where I left off a couple days ago. Yeah, it's Ludum Dare next weekend, eh? Are you asking if I'm interested to do it with you or just to participate at all? I did it once, 1 year, a couple years ago. It was really fun, actually. I was invited to join a group at work who were participating. I don't know. Maybe we can chat about it offline. You've never done a game jam, or you've never done Ludum Dare? I only did it that once, but it was really, really fun. Neither. Well, I mean, even if you go at it alone, it's I'm sure you'd enjoy it. You have an evening contract? Yeah, RenderDoc is really awesome. Especially if you're working on OpenGL. I find it really well done. So yeah, to basically to continue what I was the effort that I had started the other night is I'm just trying to understand. It looks that there seems to be an issue, and I don't like. For a while I suspected that maybe the issue, and I don't know, maybe the issue is related to OpenGL, or just some misunderstanding I have of how it works. But basically you can see here that there are certain pixels that are not being rendered, and they should be. And like this here, what we're seeing here is I removed all kinds of scale. I removed everything that could possibly get in the way, as far as I know. Here I'm rendering a 512 by 512. So that's my the texture size. Like basically you can think of it as the back buffer, what gets rendered. So with no scaling, nothing being applied, and yeah, we're missing pixels here. Now when I maximize my window, you'll see that, let's see here. Here all of a sudden I'm not losing any of those pixels, you know? So it looks to be like some kind of scaling artifact, but it's a little bit odd. Just because these lines are they come from a 256 by 256 resolution buffer, you know, if you will. Not really a buffer, but like the Vectrex, that's its native resolution, and the lines that are coming out are in that space. And so 512 by 512 is just, you know, it's just scaling everything by twice. So I just like to understand why I'm losing those pixels sometimes. Now there's something a bit odd. I don't see why I'm not seeing. Okay, here we go. So here we can see that the VS, the vertex that are coming out, what they look like here. You see, even this is rather telling. Like, what's going on here, you know? Let me see if I can... Let's see if I can control this a bit. Is this the speed here? Ah, that's better. Oh, now it gets clipped by my near plane. Or my far plane, what is it? Yeah, it must be my near plane being too much in front of me. Even though it's at 0 here. In any case, it's kind of odd that here we don't see the bottom, and yet when we look at the output in terms of texture, or maybe, do I see it here? Well, that's the thing, right? I thought I was constructing the correct geometry. Man, why can't I get close to this? It's kind of annoying. So my plan was to try to hone in on the pixels that are not rendering, find them in here, and then force my emulator to render only those, like that line, let's say, pick a line. But for some reason, in the case that does work, it looks like I can't trust what I'm seeing here, which is a bit odd. Orthographic, does that help? Okay, if I mess with the FOV, I can get a bit closer then. But still, see, I'm not seeing the geometry for the, like, the bottom lines here. Just kind of... Oh, you know what? That's very possible. Okay. Actually, that's very possible. And the reason why that's possible is because we're looking at one frame here, and the way it works is that, you know, there's no real, I don't like have a sync point in terms of like when I decide to render. I just render as many frames as I can, and this would be during a point at which these were the lines that were put in, and the beam is basically moving through and rendering this font by going forward this way, then doing the next row, you know, rasterizing this font. And I guess by the time the frame was over, the beam was, you know, in the process of moving back to start rendering the next line. So that's what we're seeing here. Now, of course, when we look at the texture, we don't see that. And the reason we don't see it, and maybe we'll see if we zoom in. Yeah, we can actually see the net result. Why we see this bottom line is that this bottom line was there from the last frame's render, but you can actually see that the color of this line is darker than the one above it. And that's because what I do is I darken the texture to 0 to simulate like the phosphor fade out, you know, from a CRT. So we can actually see the color here. 0.82, like here, 0.82, 0.82, 0.82, let's say at the bottom. Whereas if I click here, it's 0.99, right? So near white. So that explains that. Now, okay, so that's that. Now let's go back to the case where it's not working. See if we can take a look at the... So I guess the snapshot I took here, I did not have many lines to render. That's what it looks like. So I'm gonna have to take another snapshot. Yeah. It's rare that that happens, actually. Just gonna wait. Where are my vertices? Don't understand what's going on here. Take a couple of screenshots here. I just want to see if these ones work. Oh, okay. So here I got something. I've done these captures so many times and I've never really had such poor results. You know what I could do is maybe I could make my... If I force my frame rate to be slower, I'll probably capture more. Let me try something. Let's see here. Last time we got the current time. how it works. I'm going to try and wait until we've hit the 16.67 milliseconds. Okay, so that looks close to 60 FPS. So if we do captures with this, hopefully we'll get more data in our frame. What did it do? Where's my capture? Just close these. Oh, that's interesting. So because I took one capture, it doesn't show me a tab for it? Alright, so there we go. So now we actually got more. So here we see everything, which is nice. So see, like here, the left side of the C was not rendered. So let me try and pick on, like, select this one of these lines. So here we can see which, in terms of the vertex shader, what was the vertex I got? Like, I wish I could zoom in even more. Let's say we pick this top one here. Wish I could like pan. We can move with WASD, but I can't quite get where I want to get. It's kind of obnoxious. There's like no panning functionality. Anyways, alright. So let's say this top left corner is 618. .19, .16. Does it tell me which VS input it corresponds to? No, eh? I guess I go to 618 in here. Let me see. 618. Are they the same number? Yeah. Okay. 618. Okay. One, two, three. 1, 2, 3. Yeah, those are the 3 vertices there. Can I copy this? Or do I have to do export? Maybe I'll export to CSV. Oh, I can put it here. So I'll say there we go, made it back. And we open up Vectrexy. Okay. 618. Okay, so these are my vertices. Just take a look here. Same. So that's when they've been transformed into clip space. Now let me see again what they are over here. So let me export this. Okay, so now that I have this, what I'd like to do is just render these lines over and over and just see what that looks like. So I mean, I could do that in a number of places. Let's say we do it, I guess I could, well, there's const in this part here. Hello? My autocomplete is dead again. Let's clean that up. I think it's the database file here. So let's add these lines in. No, it's not quite like that. You're writing a lot of C++ 14 of late. You like it? Yeah, I think we talked about this a while back, and I was telling you would like the new C++ stuff. You know, starting with 11, and then they fixed up a bunch of stuff in 14. So making it a lot more more functional. And I'm sure you'd like 17 as well, which is what I'm using more of. Some nice stuff in 17. Like, I really love the stood variant, stood optional, those types that they added. It's pretty fast. In what way do you mean? You mean that it generates good code even when you use these newer abstractions, new language features? Yeah, yeah, totally. I mean, you know, that's what C++ tries to be, right? It's zero cost abstractions. You only pay for what you opt into. You're playing with millions of lines of vertices and it still seems fast. Yeah. I mean, there are some things that can be a bit slower, but you know, it's what you opt into, right? Like one thing I like is, so they call these types, what do they call them? They call them, yeah, vocabulary types, right? So like I'm talking about, you know, stood optional, stood variant, and stood any. These are the 17, C++ 17 vocabulary types. And basically, you know, these are just they're just really nice to use. And what's common in all of them is that they basically are they're value types, right? They behave like values. So whatever type you put in here, let's say whatever t, there's no heap allocation that's going to happen. they're going to take the size that t takes. Well, so variant, you can have multiple types. But optional, for example, you give it a type and it will store, let's say, in the simplest implementation, it'll store a bool to say whether or not it has that value in it, or the value itself. So it'll have that, you know, the size of t plus a bool. Variant will be the size of the largest value in there. So it's like a union plus you know, another field to say which one is the current one. So it's a discriminated union. And any is rather interesting. So actually oh no, sorry, it's not any of t. Yeah, any actually is one that will do a heap allocation. But any is kind of interesting because it's sort of a replacement, a type-safe replacement for void star. You know, it replaces void star for that concept of like the, you know, user data type thing. And so what it does is it'll do the heap allocation and the freeing for you, and it also stores, as long as you have that enabled, the RTTI information for the type of the thing you stored. And in order to get back the thing in the any, you have to ask for it by type. You know, you say, I would like, you effectively cast your any to the type, and it's not a real cast, or it's a checked cast, you know, kind of like a dynamic cast. So it'll make sure that your type is the type you're storing in there, it is what you expect. So it avoids a lot of the common errors we have when we use void star. It avoids the heap allocation errors that we often run into, and it avoids the, you know, accessing the data as a wrong type errors. Now, of course, it's not a zero cost, right? But if you're willing to pay for that abstraction, you get the type safety and memory safety that comes with it. So I really like that. I like that we have these types in 17. And I've used them, all three of these, in my code. I have one use case right now, but the other ones I have a few. So definitely some nice things in there. And these are not the only ones, but yeah, some good stuff. Okay, so what am I doing here? I want to make a line. I need to put a brightness value. That's the only thing I'm a bit interested here is, what did I do with brightness? It's a point, and a brightness. But I have 2 points here, I have 1 point. And even when you can't go fast enough, you go down to a simpler type and implement exactly what you need. Yeah, exactly. That's exactly right. So no premature optimization, right? You optimize when you need to. Because man, it's getting much harder to tell where your speed's gonna go, right? That's what I'm finding. You know, like years ago when we had like simpler, you know, back in the 486 or even, you know, 586, the Pentium and all that, it was, you know, you'd mainly write single-threaded applications, and you'd be able to look at your code and go, oh yeah, this is going to be slow. But now, man, my intuition about what's going to be slow and fast is almost always wrong. Like I'm like, oh, I'm sure this is the thing that's going to cost me tons of time, and then I go and I optimize it and find it has absolutely no bearing, or I'll rather than try to optimize it, I'll profile it and it doesn't show up at all, and I'll be surprised at the things that show up, you know. Right. Yeah, there's actually quite a lot of complaints about unordered map being rather expensive. I haven't looked too deep at the details, but unfortunately it seems like it's not the most efficient implementation of a hash map. But yeah, I think they want to add some types of C++20 for stuff like that. Like, I know they want to add, I forget what they call it, but basically, you know, a map that is backed by a vector. You know, like a vector map. I think I've seen that in EASTL. I think they call it vector map. So that you get, and I don't know if it's sorted or if they do like a linear search, maybe they do a binary search for the key in there. But the point is that because your data is contiguously stored in your vector, you get the cache friendly lookups, especially for smaller maps, right? Yeah, big loops, exactly. Okay, so just try to focus here, just to give me a sec. So I've got, where was I? I'm up here. 618, 618. So 50 to 41, and then I want this one here, I think. Yes, exactly. It's all about cache. I want to see if this actually compiles. Okay, good. See, this I love. C++ 11 with the aggregate initialization like this, where I don't have to put... I mean, although we had a form of this anyway before, but the uniform initialization is nice. Okay, actually, you know what? Let me do this. Copy the next line. Oh yeah, so I wanted this to there, then this to there, and then finally back to the first point. Okay, so this should be those same lines, unless I messed this up. So let's see what this looks like. That might be right, but it's interesting how now it's rendering. Let me see on the like positionally if it's at the right place. Let me take a screenshot. Function Alt on screen. Wow, that frame rate's pretty bad, eh? Anyway. So 514 by 544. And then if we disable this, no, that doesn't look right at all. Okay, you know what? We can determine if these values even make sense. But it's rather surprising, isn't it? Anything stupid maybe I'm missing here? Let me think for a sec. There should be no scaling or anything being done to these lines. These should be set to 1. Wait. Oh no, that's true. I do have a scale to apply. Right, because I'm no longer using the orthographic projection to do the scaling for me in the shader. I'm doing the scaling myself. So that means that I now need to apply that same scale here. So since right now I'm gonna have to do the same thing here. All right, that's okay. Okay, let's do this like this. maybe I'll do it like this. Oh, that's it. It's because these values have been scaled. What we're looking at has already been scaled in here. Ah. Huh. Okay, I just realized that. So I actually need to just divide these. Okay, so... Alright. This kind of sucks, but okay. Fuck it. So I know that I basically have to have these. What's the problem? Yeah, so that's exactly what I was doing before, fake Pyre. And the reason why is because basically I have two approaches to do this, but I'll tell you the reason. So the issue has to do with the fact that despite the Vectrex being a square space, so 256 by, I'll put my hands up, 256 by 256, the Vectrex screen itself is not square, right? The actual screen, think of the CRT, it's actually more of a 3:4 ratio. It's a 4:3 that's been rotated 90 degrees. And so what that means is that when I try to render my lines, I try to render these lines as actually two triangles. But what happens is that there's a skew that gets applied due to the scaling that occurs when I render this square space into a non-square output, right, or viewport. And so there's basically two approaches to solving this. One approach is to kind of undo the skew by reapplying the inverse scale when I'm drawing my lines. So being aware of the scale that's going to end up, let's say the skew that's going to end up, kind of undoing the skew when I draw my line so that it gets corrected by the time it gets scaled, right? Or to do what I'm doing now, which is do the scaling myself on the CPU and then just draw the lines as is because they're in the native resolution that they're going to be drawn, if that makes sense. So rather than do everything in 256 by 256, I do it in whatever actual resolution I've decided based on the window size. And then I scale all my points in this new space, and then I just draw the lines, and when I draw the lines, I don't have to do any corrections because they're going to be drawn exactly as is. So hopefully that made some sense. But yeah, that's a good question. So maybe not, right? But you see, I've been trying to track down why I have these missing pixels, and one of my theories was that maybe it was due to the skew. So I thought maybe what's happening is that when the pixels are skewed, they end up not, and like when it gets rasterized, they don't get rasterized because now they kind of miss the center of the pixels, So to kind of remove that from the equation, I said, look, I'll just make sure that there's no skew when I'm drawing my lines. But as it turns out, that's not actually the issue because, well, I say it's a form of skew, right? Because basically I'm stretching in X and in Y. So I guess I'm squeezing in X, you know, and I'm squeezing a little bit less in Y, normally. So Fake Pyre says another option is that you can have the shader itself thicken the lines rather than generating thick line geometry on the CPU. Yeah, Lisp Gamer, you're right. It technically is a scale. It's a scale. It's a, you know what it is? It's world scale, right? So that's why I say it's skew, because in this, you know, if you have a line that's not straight, right? And, you know, you have these ends, maybe my hands are, let me see if I can get this right. If you have these ends that are supposed to be like this, they end up, you know, getting skewed this way. And that's what I mean when I say skew. Because of the world space stretching in X and Y. And then in the local space of the line, this world space scale ends up making the edges look skewed. Does that make some sense? I see what you mean. But like, you're saying skew would offset in a direction. Yeah. I guess in the end, the net effect is more like a rotation. But yeah, it is due to scale. And I think we understand each other. So yeah, Fake Pyre, you're saying that yes. So I did read about different ways to implement lines. I think what you're suggesting is, you know, don't actually do it on the, you know, I think I saw one way is you can submit, like what I'm doing on the CPU, we could actually do it in the vertex shader even. You could submit your points twice, along with information like the binormal at each endpoint, and then the vertex shader can go ahead and like shift the point along that binormal at the ends and effectively create the same thing I'm doing on the CPU. So I don't know if that's what you're talking about. That's one of the strategies I've seen. So that just basically offsets that to the vertex shader, which is probably faster than what I'm doing. But you know, I'm not really having an issue of performance here. If I was, you know, that's definitely an option. Try to offload more to the GPU. But right now, it's more just a bug, you know, just trying to fix a bug. Oh, all right, Lisp Gamer. Thanks for hanging out, and I guess I'll see you next week. All right, man. Right, so the vertex shader can shift, expand in screen space, so even a non-uniform scale results in unskewed rectangular line quads. That's true. Okay, I see what you mean. Okay, I didn't get that element of what you were trying to say. Okay, so you were suggesting offloading to the GPU not as an optimization, but rather to also solve the problem of the skew or the shift or whatever, the scale. Because once we're in screen space, then everything should work out. Yeah, that totally makes sense. Because by then we've already been projected, right? So we're now in a space where, yeah, there won't be any more effect. Yeah, I like that. It's kind of like we're behind the fence now, so we have to either, you know, we have to worry about this problem, but we can go beyond the other side of the fence post projection, and then yeah, no, that's really interesting. It's really interesting. Yeah, you know what? I'm gonna take a note of that. Yeah, so yeah, let me just take a note of what you said because I don't want to forget it. That's actually a really good idea, and it's something I can explore. You know, maybe once I get this stuff working. Consider moving thick line generation code to the vertex shader. This will not only be faster, but will allow us to go back to using ortho projection to scale from Vectrex space to whatever screen space, and we don't. I can say we can generate our lines along binormals without worrying about scale skew anymore because we're already in screen space. Alt-C there. Okay, cool. So what's the actual missing pixel issue? So let me see if I actually did this correctly now, and you'll see what it is. It's interesting because actually we see it here. So this is not missing when I render it this way. So that's kind of a very interesting find. But let me just make sure that this is actually at the right spot. I'm not sure it is. Oh, I think it is. Okay, so let me see if okay, let's create a layer here and let's paste this on this layer. And let's select yeah, okay, there we go. That's cool. So like I'm zooming in here, and I got the second layer here, which is the pixel that is actually missing on the base layer. It's one of them. So see, it's interesting, right? Because then it looks to be some kind of rendering issue this time. So when I normally render the screen, I'm totally missing this whole row of pixels here. Well, it's not really a row, but I'm missing this one and the next one and the next one and the next one. You know, that would make up the C. When I only render, but the thing is, those vertices are going through. They're being sent to the shader, and in fact, so here's render doc, right? Like, so here's where the problem occurs. If we look at the texture viewer here, you can see that the C is missing those pixels. And yet, when we look at the vertices, which is down here, the C has those pixels. And so what I did was I selected the vertices. I don't know why it's not working, the selection right now, but I need more screen real estate here. Yeah, that's it. So what I did is I selected these pixels. And I looked at the values in here. So basically it's these ones here, starting from 618, 1, 2, 3, 1, 2, 3. And I took those, and these are in screen space or clip space. And I think it's clip space, right? When it comes out of the vertex shader. Yeah, I think so. Anyway, and over here I have them in input values. So I took the same 6 values, and what I do is I went in my code and I forced those, and I cleared my lines array, and I just put those in there. And how wide is one of those missing segments in pixels? So the answer there is, so before I say that, like basically just to be clear, the resolution of the Vectrex is 256 by 256, right? But my current texture is double that, so 512 by 512. So that's what we're seeing, and these values therefore have been scaled up to 512 by 512. And so what I do is I divide by 2 here to get them back into like what, you know, Vectrex space. And so you're asking how wide is one of those segments, and the answer is basically going to be here, right? So let's say 39.8 to 41, but this divided by 2 in terms of Vectrex space. But in terms of like pixel space, in this case, it is really this distance. So what is that? It's exactly 2, right? So 2 pixels. It should be 2 pixels, even though it ends up looking like, let me see, does it look like 2 pixels in here? Yeah, I think it is 2 pixels in here. Let me try. Go on this layer. So 2 pixels wide and 2 pixels high. So let's look at the height difference. Oh, sorry, that is the height difference. In terms of width, 50 to 51. So actually, it looks like it would only be 1 in terms of width. Interestingly. Yeah, because this is X from here to here, Y from here to here. So when I increase my output resolution, it works. And we can see that because I can just scale up my game and it'll work. So let's say we'll go back to false here. So we'll go to the normal case. So it is related to resolution, but it's still surprising to me that at like 512 by 512, that I would be missing pixels. So, okay, I'm just gonna get to the part where we have the issue. It's just here. So you see that C is missing its pixels, but if I increase, well, okay, it was hard to see, but I think you might have caught it. There. We can see that the pixels are there. But then if I go back to here, they're missing. But interestingly, if I only force those pixels, they actually appear at this resolution. See here, they totally appear. Huh. It's funny how it looks when I increase the resolution though. Doesn't look square. Yeah, it's really a weird shape, isn't it? This here is really weird. Let me, what I wanted to do now is I wanted to capture using RenderDoc with this 1 pixel being rendered, just to see what it looks like in here. Can I actually launch another RenderDoc? Might prefer having a second instance for this. Yeah. me see here. Definitely 4. Yeah. See the mesh output? Oh, so it's got the weird shape here too. Did I like mess this up? Let me see. It's really hard to control this thing. No? The hell? I don't understand why I cannot pan my camera. Let me see if there is a way. Left click pans moves the camera. What is this? What did I do? That does not look at all like two triangles. I must have messed this up. Let me see. 1, 2, 3, 4, 5, 6. Super strange. Isn't that beautiful? Let me see that. What's going on here? So we take... I'm modifying these lines here. I wonder if this const cast thing is somehow screwing things up. I don't really see how come. We will get to the bottom of it. What's really weird is that we saw that quite clearly, at least when it rendered, it like did the right thing here, you know? It's pretty crazy. So maybe it's just something in RenderDoc that's looking weird. So here I have 389,000 lines. That makes sense. What? I don't know. I don't think I can trust what I'm seeing here. Oh no, I don't have. I did not initialize it yet, so it's still 0. Okay, whatever. Okay, let's do this. Okay, now I have 2,000. Yeah, that's about right. This is the order of magnitude I expect. About 2,500 lines. We clear it. We push these back. So now we have 6 lines. Okay, let me take a look in RenderDoc at the values for our vertices coming in. Oh wow, okay, there's way more points than should be here. What? Oh no, wait. No, sorry. What am I saying? Is this right? 1. Yeah, it does seem like way more points. Yeah, it doesn't make any sense. 1, 2, 3. Should stop there. Do I start again? What is this value? 50.5689. That did not show up. 1, 2. So 41 is here. So one question is, where did this 38.83755 come from? Unless what? No. Yeah, I don't know. Let me see what happens here. Oh, look, 36. It's not triangles I'm supposed to put in here. Okay. Alright. I'm supposed to just put in the positions of the line. Okay. So actually, it's not the lines that I want to modify. It's really this. It's this lines vector that comes out when I transform lines into my buffer of vectors that I will send to the GPU. That's actually what this should be. Okay. Yeah, this makes sense now. Okay, so I'm just modifying the wrong thing. My lines don't contain the triangles in them. It just contains the lines in Vectrex space. It's like the higher level lines, you know? Okay. So instead of that, what we'll do okay, so this is my vector of vertex data. So it's really here that I want to do this. I think I can mostly reuse what I put here. But instead of this, we're going to put vertices. Which is a vector and a brightness, so that should be very similar. I think I can literally copy these here. Including the brightness value. Can I just take all of this? Oh yes, okay, right. Yeah, I know what I'll do. Did I get that right? I might be missing, yeah, I'm missing a brace here. And there's also a brightness value missing, but I don't think it really matters. But we can put it. Let's just for completeness. It's gonna be inside here. All right. So what I actually expect is for it to be all black. But see, it's all black now. But let's take a capture and see what it looks like. Oh, I was not supposed to divide now. Must say, I really love RenderDoc. Such a cool tool. Alright, so those are the points that we are trying to render. And now this time we don't see the vertices in this view. Which is interesting. Oh, there it is, okay. That makes more sense. Not exactly what I expected to see, though. Did I not do it right? Oh, that's not right. Maybe a copy paste error? Oh yeah. Oh, I see. I should only have 6. Oh yes, that makes sense. There to there, then. This is rather confusing. Let me see. I know what I'll do. I think I copied it into VS Code. Okay, let's do this. Hey BD, how's it going, man? You're up late again? Yeah, I'm pretty good. Getting deeper and deeper into this debugging here. Okay, so still black. ABD, remind me again. You're in Europe, right? I think that's what you told me. Was it Germany? Or am I like mixing you up now? No? Wait, you told me that. Okay, yeah, no, I'm mixing you up with someone. So you're in Toronto. Oh, okay. So you're not too far from me. Yeah, I'm mixing you up. Sorry, man. It's hard, you know, like the names, because like there's no faces attached, and so I just see names, and yeah, it's like it's interesting how like when you guys see me, right? You see my face, and you associate my name to this face, but like it's hard for me because I just see names in the chat. But anyway, yeah. So you're in Toronto, so just 6 hours away from me. 6-hour drive. Yeah, Montreal, exactly. Okay, so why do I only see a triangle? Highlight vertices. I did mess this up, didn't I? God damn it. Yes, okay, I see it. Jeez, man. It is really hard to get this right. Maybe I should just recopy this. This is so confusing because I keep switching between two different IDs here, and the keys for like column selection, oh, damn it, they're not the same, so I keep messing this up. That's why I hesitate when I have to do this kind of column selection stuff. Like this. Okay. Yeah, I can see the errors here. There. And this one should be okay, but just to be sure, repaste it. All right. And are you studying in Toronto, ABD? Or are you the one who works? Quick question. Yeah, you're studying, okay. I've always seen people online who work as tools programmers. Oh, you're in high school. Okay, so you say a lot of people who you see online programming identify themselves as tools programmers? Because I don't think I've ever said that. I don't think of myself as a tools programmer. But I can explain what I think that means when people say it. So I think when people say they're tools programmers, like tools is kind of general. Yeah, that's fair. I mean, anyone who programs at some point will write some tools, right? But yeah, as a profession, usually what that means is, like, so let's say I speak in the context of video games, because that's what I work in, but this does really apply to pretty much all software engineering. So in the context of a video game, we have different, I guess, types of developer positions. So I just want to make sure that I got this right. Just give me a second. Holy crap, finally. Okay. So yeah, basically, when you think about a game, let's say video games, we'll have different kinds of programmers. I think that I consider like in my mind anyway, this is just my separation, and it's a bit arbitrary, right? But I kind of see like the video game development, you have to say at the highest level, there's this one separation of programmers where you'll have the game programmers versus the, say, systems programmer. Okay, and so the division there is that games programmers are the ones who are actually doing most of the work for the game itself. So they are doing tasks that the net result of what they're doing is towards making the game itself, you know, like doing things that actually show up in the game as gameplay stuff, you know. So this can be things like, you know, player, camera, the controls. It can be like AI. It can be things like what else? You know, I don't know, and things that you see in the game that are related to the game itself, as opposed to systems programmers, who, although they are working in the same code base, they tend to focus on things that are less game specific and more general, right? So solving issues more at a lower level in terms of code. So stuff like, you know, working on the networking or the audio, or you know, animation systems, profiling, memory, things like that, you know. So those are kind of like systemsy stuff, right? And there is perhaps a third group, but there's a lot of overlap in the third group in terms of being both a gameplay or systems programmer, and that's the tools programmer. And the way I like to think about that separation is the tools programmer spends their time working on the tools that are used to make the game. So, for example, most games are made with some kind of editor, right? And so a tools programmer will often be someone who works on the editor, making it you know, either fixing bugs or adding features, just making it a better workflow, improving the experience. Another example of things that a tools programmer might do is work on stuff, not, let's say that's the editor, but let's say you're an artist and you're working in a 3D animation package like Maya or Max or something. A tools programmer may be the one who works on the export pipeline from Max into your game engine, you know, or into your editor. What else? Tools programmers may also be the ones who will work on tools for your build system, right? So a lot of times you have some fairly sophisticated build systems required for games because you have so many assets that you have to crunch through and package and put them together so that, you know, you can efficiently load them or compress them and all these things. So tools programmers will often work on that. Now again, you know, to me, you know, anybody can work on tools, a gameplay programmer or a systems programmer. Usually, because tools are more involved, you'll have more systems-y-like people working on it, but that's just completely arbitrary, right? So does that sort of clarify a bit for you what the difference is there? So I think when someone says they're a tools programmer, what they mainly mean is they don't work on the things that the public see. They work on the like their main clients are not the public. Their main clients are the team. I think that's a nice way to say it, you know? So if I'm a tools programmer, my clients are my fellow developers who are working on the game. Whereas if I'm a gameplay programmer or even a systems programmer working on the game, my clients are going to ultimately be the people who will play the game. Okay, so this is really interesting because we see the same thing that we were seeing on the other end. So we have our two triangles, right? And we do not see them rendered. They're not being rasterized. And this is all I'm rendering. Okay, so that's the what we see in this pass here is the result of the draw for imgui. I'm trying to see what is this other draw called again here. Oh, this is when we draw the screen itself, the texture of the screen. So is there anything weird to see about here? Why do we not see anything in the texture output? Rendered texture. Right, we don't see anything because the output is black to begin with. Right, that makes sense. Like we actually had something showing up here, then we would show up in the next turn. So I'm curious who it is that you watch that streams that identifies themselves as a tools programmer. You know what would be a really nice feature in RenderDoc is if when you scroll with the mouse wheel, So this is something that Unreal Engine does. When you're moving around with WASD keys, if you scroll the mouse wheel, it changes the speed at which you scroll. It turns out to be really, really nice for moving around, because you see what I keep doing is I keep coming back here and then making this a little bit slower as I get closer. But I keep naturally trying to scroll down as I get closer and closer, and scroll up when I want to go move around fast, you know? So maybe it's something I could do. RenderDoc is open source. Ah, okay. Okay, you were looking at jobs. Alright, that makes sense. Well, hopefully I cleared that up for you and you'll know. Honestly, I find tools really fun to work on as well. It can be really rewarding, because the immediate feedback you get is from your fellow developers, and you get to work with them, right? And one thing that's fun when you're a tools programmer is you get to sit a lot with artists and watch them work and watch their workflows, and you have the pleasure of trying to improve their workflow. A lot of times you'll watch level designers, artists, that's other people working with the tools that are there, and you expect them to work a certain way, and then you see them doing certain repetitious tasks, or doing things that take much longer than they should in your mind, and you realize that there's limitations, or they're working around limitations, or there's assumptions, and so as a tools programmer you get to clear that up or help them with that, so it can be really quite rewarding, especially when you know that those little workflow improvements end up making them faster and making overall the game better, Interesting. Exactly 0.9. Is there other? And this should be 2. Now this should be 2 because I actually am the one who sets the width of the width of my, what's happening here is that we're drawing a line from left to right, and you can imagine it right from this in the center here, and then what I do is the line thickness, which is set to 1, means that we want to draw 0.5 above and 0.5 below, which actually, why would it be 2 then? That's kind of interesting. Oh no, sorry. It's only 2 because we've doubled our values because we're in 512 by 512. Yeah, so really this is more like .45 and 1 in 256 by 256. So yeah, basically we have a very, 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 very small line here. So I guess, I'm going to say, I guess it makes sense that when you increase the resolution, even though I'm scaling these values to match, when it comes down to it, when I think about, I guess when we think about pixels, you know, like for example, if we were in 1024 by 1024, then this, you know, this delta here would be 1.8. Okay, just give me a second. Sorry about that. So yeah, I guess I'm thinking now that at 1024 by 1024, this delta is 1.8, and I guess that we're looking at discrete pixel values here, right? So anything that's too small, I guess anything less than 1 maybe just doesn't render. So just to test that theory, what if we make this 0.1 larger? Will we end up seeing it? You know, really what I should be doing here is something more like, I'm never gonna get it right. Okay. 51. Let's just do that and see what happens. Yeah, and there we have it. As soon as I make it 0.1, Like as soon as I make it 1 in width, we see it. So then is there like a... I guess there is a... When it comes to rasterization, it's got to look at whether your triangles really fit within a 1 pixel boundary from center pixel to the next center pixel. And I must be just missing those markers. Like if this is just under, would it actually round it? So 0.9, let's say. Would this work? Oh, I forgot one. Okay, so that still worked. I wonder what the limit is. Okay, let's go for 0.05. It's possible that it just needs to be 0.5 away to cross the threshold. I should really put a slider on this. That's what I'm going to do next. Oh, and now it's gone. Thinking about what this all means, what strategies I can use to mitigate this issue. So in this case, a very small addition. I wish I could understand it more. I wish I could really see it. I'm trying to think of kind of like I was saying, mitigation strategies. What would be the right way to handle this, you know? Okay, so let me just try something. So if I go to options here and we go back to the 256 by 256 case. It's gonna be very small, but I just want to see if I can reason about this. So I can't see. Okay, there it is. Okay, there it is. So this is the one. Let me start again. So we have 0.045, right? So if we put this at, it's not fun, we can't see anything. So I guess if we put 0.55, yeah, the point appears because it's at least 1 in width. And probably less than that is required, like we were seeing earlier. One pixel, so 0.45. 0.45. This is 0.55. So what? Maybe it just needs to be 0.5 for this to work? No, not even. Still less. But close. We're now at 0.49. So like maybe the strategy here, maybe one mitigation strategy would be something like I mean, I don't know if it's a good idea, but let's say we went into our screen here. I'm trying to think, like, maybe if I could enforce a minimum width. But maybe it's not the right place to do it. I don't know. I'm trying to think what's the right place to put this. The issue is that I can't really do it on the rendering side because I don't know, in terms of lines, I don't know what was the source line and what was the destination line. Although maybe I do because of the order. We always add the source in P0 and then the target in P1. So I guess we could assume that. And what I could do is I could say, if the length of our line here, this, P1 minus P0, if its length is less than 0.5, we nudge up P1 along that line and just make it 0.5. At least make it 0.5 in terms of distance. So we just nudge P1 along. Now this could look wrong, if we have a circle being drawn with very, very small distances across. This could actually end up making little points jut out of the edge of the circle. But then again, probably a circle would never be drawn with such tiny lengths on the Vectrex. I don't think it would have enough time to do that kind of thing, I think. Anyway, we could try it, right? Let's give it a whirl. See, for points, we don't really have that problem. For points, we basically enforce that we draw a quad that is going to be the size of line width times line width. So that doesn't happen here, but it's really in the line case. We do the work of making sure we have the width along the the thickness of the line, and that guarantees that we see it in that direction, but it's really the length that we don't guarantee anything. Actually should be like this, and this here should be called like binormal or something. This should be called normal. The length is less than 0.5, then let's move P1 It's not really the length of the line, is it? We have to look at the components of our vector separately. Does that make sense? Yeah, I think so. Let me just see if this works for x, because that's what the case we're looking at. Oh, it's not that I want. No, that doesn't make sense. Hold on. No, that's not right. I do need to take the normal into account. Yeah, it's not right either. Ugh. Starting to get tired. What is it I'm thinking? Let me try this. This won't change anything though, because we were actually hitting this breakpoint, but I'm just going to pay more attention to the values we see. P0 and P1. Those should correspond to 29.5 and 29.1. So actually we are going from right to left in this case. Right. Negative, okay, we're going from left to right. Yeah, sorry, negative 29.5 to negative 29.1. So that's normalized. Okay, looks good. And now P1. This is the value of P1 before. Now we're going to take the X value, we're going to take the normal. Oh yeah, the normal, yes, and the normal will have the sign correct. So that's why I'm using that for the sign. And then P1 will become like this. And now if we were to do P1.x minus P0.x, we get exactly 0.5. Now what if we were to just increase our min pixel distance? Let's put 1 just for good measure. Wait, is it just being hidden and I can't see it? Shit, it was just being hidden. That feeling when things are just not working out. I don't know. Don't know what's going on. Yeah, this is not quite right either. But still, I don't understand why we don't see the point. Oh, okay. At least that's 0, so that's okay. But yeah, we're definitely making it have at least 1 pixel difference here, and we're rendering it with that. Oh, wait a minute. That's embarrassing. I think my stream videos are proof that the more tired you get, you know, like basically there's like a pattern, right? At the beginning of my stream, I'm sharp, and I'm able to think about these problems, and then as I get to the end of my stream, I start to get slower and I start making more mistakes, and it's totally a pattern. We could like data mine my stream videos to like understand how programmers' minds work. Sadly, I'm still missing pixels here. Oh. Oh, putting a min distance of 1 may have done the trick. Look at that. I mean, I don't know if this is great, but it certainly looks pretty good. Oh, what do you know? Yeah, it really needs to be 1. I mean, I don't know if I'm getting skewed, like, because of this. I think maybe at such a small resolution, we're going to start to see a little bit of skewing in the exposition of certain lines. Like here, I don't know. This looks a bit funky. I don't know. Let me see here. Maybe not. Let's say we take this just for comparison. I'll just look at this 8 and this 3 here. I mean, it's fine. I just wanted to kind of take a look here. And I think we see a little bit of the artifacting, right? Like, you can almost tell, you can pretty much tell that we're drawing from left to right. Like, this end for the 3 ended up being pushed inwards because it made it longer this way. But then again, you know, it's hard because we're scaling here, so... But you know what? I'm going to consider this a victory. It looks now like we can finally see all our pixels. Pretty much, you know? I mean, there's maybe some bad cases, but for the most part, you know, in any resolution that's actually usable. And I think we're seeing something that's actually resolution independent now. I might have to do something about how thick it looks though. Now if I was to play with the thinness, why is it so slow? Is that my optimization being turned off? Probably. So basically what we've done here is we've said any line segment must be at least one unit wide, but both in X and in Y components separately for pixel coverage. Oh yes, I know why it's going slower. We made a change in SDL engine for capture purposes, which gives the illusion that we're going slower because when we do our frame timing, it's not quite correct now. So it should be okay. Basically, if I just remove this do and this while here, or I just say while false, that should be the same as before. Yeah, this is what I was worried about if I go too thin. It's the same problem, I guess. It needs to be at least 1. I have to do the same thing for the line width. This way I can make it thinner when at higher resolutions. Because the width is actually scaled based on the resolution. So we just want to make sure we don't go too small when we're at low resolutions, but at high resolutions we can make it thinner. And then it won't be completely resolution independent, I suppose, but there's a limit to how, how small we can go for it to look right. Which is the same case here. Yeah. All right, just 1 second. All right. So I'm going to stop here. My closing thoughts are that this is working, and I think this is the right solution. I'm going to just think a little bit more about it, but I believe that this is the right thing to do, is make sure that at the lowest level, when we're about to generate vertices for our lines, make sure that the lines are at least 1 pixel both in height and width, which means that we get a full pixel coverage, right, for our line. And we do this at the component level to make sure of that. Now the next part of this is the width. That's the thickness of the line. I have to do the same kind of treatment because, as I was just showing now, I find that the lines are much too thick at normal, say, quote unquote normal resolutions, right? So let's say we'll play mostly like this. I find this much too thick, right? So I'd prefer to have it more like, something like this. This looks way better to me. And you know, we're gonna make sure to enable blur and all that, right? But I want thinner. But the problem now is that if I make it too thin, when let's say so-called normal resolutions, at some point as we get smaller, the lines will start to disappear, as you can see here. Like even let's say I reset here, the left side pixels are no longer there on the Vectrex. We're missing a bunch of pixels here, and it's the same problem. Basically, we've reached a point where at this thickness, we are no longer guaranteeing a minimum of 1 pixel coverage. I also want to think about whether this is something that I can just solve in the vertex shader. I'm not sure actually. Maybe not. Maybe it won't be solvable. Or at least maybe partially. Going back to whether or not I should be doing the thickness on the vertex shader side. I mean, I guess in fact, the line width here let me try this. This might actually be the solution. The scaling of the line width does happen on the outside. Oh, there we go. So now we get to have our line width as thin as we want, and there is and you can see it, like a certain threshold, it just stops getting smaller. Yeah, there's another problem here. I didn't disable the spam. Change my error policy so that we don't get that. Just want to try this again. Looking pretty good. So we can choose something decent for like normal resolutions. Just a double check here. So basically, at line width normal, at this resolution, we're getting, see, a line width that's been scaled to 0.88. Even though we set the scale to 0.2. Yeah, so this is a scale that's based on the current resolution. And then when we come in, it's 0.88, so that will get clamped to 1s. So right now it's technically going to 1. So yeah, we're definitely, like, there should be no difference here, but let's say at point, looks like at 0.3 we see something. 0.3 must pass the 1 threshold. Come here, yeah, 1.3 we're okay, so that we're gonna maintain. But if we make this resolution smaller, suddenly our line width is 0.5, and then that's gonna be made at least 1. Yeah, I think I can live with this. This is pretty good. Okay, so guys, I'm going to stop the stream here. I think we did some good work. By next time, we'll clean this up and we'll bring back everything online, and we should be in good shape for this to look right on pretty much any display. So very happy with that. So guys, thanks again for watching, and see you next time.